So today we're going to be talking about chemical world and atoms. And you guys don't need to write everything down up here. I'll tell you guys what's important. A lot of this you guys read in the article last time. So I'll tell you what you have to write down. If you want to make some notes on your own, you can. But please do not copy all this down. It's kind of a waste of time for you because this is already on Canvas anyway. Okay. All right. So last time when we met, you guys read that article that talked about matter, right? So matter is going to be anything that has mass and volume, basically anything that's physical. So think about solids, liquids, gases. You're probably not too familiar with plasma. We won't talk about plasma, but anything that's a solid, liquid, gas is going to be made of matter. Okay. You guys probably learned that in your old science classes. Non-matter, we talked about this before too. It's anything that does not have mass and doesn't take up space. So things like energy or abstract concepts like freedom, right? Emotions, time, things like that are non-matter. Okay. All right. So let's get into the actual chemistry stuff, the main part for today. And I want you guys to write this part down, the part I highlight. Okay. But all matter is made out of these tiny things called atoms. Okay. All matter is made up of tiny particles called atoms. And you guys don't need to write down the next part, but just to kind of help you guys get an understanding of how tiny these things are, you get a single drop of water. There are a billion trillion atoms inside of that single drop of water. So the amount of atoms there are and just how small they are, it's kind of hard to imagine. Just know they're super duper tiny. Okay. Yeah. What's up? What was that? Yeah, of course. So today we'll be differentiating between atoms and molecules. We talked about, or it was in your article last time, but just to kind of clarify things. One way I like to think about atoms is they're kind of like when you have Lego blocks, right? You got the individual pieces, right? There might be the red one, the blue one. Some of them are short, some of them are long, some of them are skinny, some of them are fat, right? They're all different Lego blocks. They're all individually different. Okay. However, when you put them together, you get these things called molecules. Just make sure you write this part down. You don't need to copy down the bottom right here. Okay, but when you put the atoms together, they form molecules. Okay, so atoms are the Lego pieces, and then molecules are when you put them together and make a spaceship, right? A Lego spaceship, when you put them together. Okay, so again, just to reiterate, atoms are the individual Lego pieces. You put them together and you get one molecule. Okay, so I got some examples right here. So the first example right here is a CO2 molecule. CO2 is carbon dioxide, is what you breathe out. And it's one molecule. So this is one molecule, but it's made out of 3 different atoms. You got 1 carbon atom and you got 2 oxygen atoms. Okay, so you put the atoms together and then you make a molecule. Does that make sense? And obviously, we got another example here with water, H2O. It's made out of 2 hydrogens and 1 oxygen. And you guys don't need to copy that down. We actually aren't going to talk about molecules too much for a bit. We're going to start with the atoms and then kind of go bigger from there. All right. Okay, so well, let's talk about what atoms look like. So atoms are made out of 3 different things. And unfortunately, I'm going to ask you guys to copy this part down. You guys don't need to copy it word for word. If you can kind of just summarize it in your own words, easier for you to read, you can. But atoms are made out of 3 different smaller pieces. They're called subatomic particles. And these are the 3. Okay, so I'll give you guys maybe about a minute to copy that down, and then we'll go over them in detail, and then we'll draw a picture of where they are in the atom. So the first subatomic particle are called protons, and they have a positive charge. Now, if you don't like writing the full name protons, I personally don't. A way that you can abbreviate it is you can just write a lowercase p and then just put a plus sign on the top right. So if you ever write that, I'll understand that as protons. So just to kind of save you some writing time, you can always just denote protons as the P and the plus sign. Periodic table, right there. Same thing for neutrons. They also have a little shorthand you can write for that. So for neutrons, it's no charge. So you just write an N, and then you can just put like a 0 on the top right, and I'll understand that's neutrons. You can probably see the pattern here. Electrons, you can just write an E, and then a minus sign on the top right. Okay. So atoms are made out of protons, neutrons, electrons, and then you can write them like that just to kind of save yourself some time. Okay. Okay, so let's talk about where these things are inside of an atom. So in the very middle, that's where the protons and the neutrons are going to be. Okay, so the protons and the neutrons, they're in the middle of the atom. So you can just draw something like this. Okay, protons and neutrons are going to be in the middle, and they are stuck together. And this middle part where the protons and the neutrons are, this part is called the nucleus. Okay, it's kind of like in biology, you know how the middle of the cell is called the nucleus. Same thing with chemistry. The middle of the atom is called the nucleus. And that's where the protons and neutrons are stuck together. Okay, so on your assignment today, and I'll do some practice problems later, I'm going to ask you to draw an atom. Just make sure you know the protons and neutrons in the middle. And then the electrons, the thing about the electrons is they're around the nucleus, but they are not stuck together. So they kind of just fly around on their own. So we just kind of put them around the nucleus. Okay. So that's going to be what an atom looks like. In the middle, protons and neutrons, and then electrons fly around the nucleus. Again, you don't need to draw it exactly the way I do, as long as you get the general idea, whatever helps you remember it on your notes. Yeah. All right, any questions so far, or is this like mind-numbingly boring and easy? Okay. All right, so let's move on to the next part. So now we're going to be taking a look kind of at the periodic table. And you guys don't need to write this part down, but the number of protons that an atom has, it tells you what element it is. So take a look at your periodic table right now. You see how there's all these different elements, right? They all have different names. They're all in these different boxes. Those different elements are determined by the protons, okay? And we'll talk more about that in detail. And this will be later in the unit, but the neutrons tell you something called the isotope. The electrons tell you the charge, but this isn't important, so you guys don't need to write this down yet, okay? All right, one thing I do want you to write down is this part right here. For today, I want you to assume that every atom has the same number of protons and electrons, okay? And if you want to kind of just write this the same way, okay? For today, just assume there's an equal number of protons and electrons. So on your assignment today, if an atom has 12 protons, just assume it has 12 electrons. Okay, if it has 3 protons, assume it has 3 electrons for today. Okay, it'll change later, but at least for today, you can assume that they always have the same protons and electrons. Okay, so let's get into kind of what the majority of your assignment and is going to look like. But the key thing for today is, like I just said, the number of protons tells you what element an atom is, okay? And so depending on the atomic number, so the atomic number is this number on top of the box in each block of the periodic table. So every single periodic table should have a number on top of the box, and that's called the atomic number. And that's going to tell you how many protons there are. So hydrogen has the number 1 on top. So hydrogen has 1 proton. Super simple, right? Okay, xenon, Xe, has the number 54 on top, so it's going to have 54 protons. Okay? That's it. That's pretty much the main skill for today. So, with that being said, I want you guys to take some time. I'm going to zoom out a little. Actually, I'm going to scroll down a little. Okay, I want you guys to take a second to answer number 1 and 2 on your paper, on your note paper, okay? I want you guys, based on what we just learned, I want you guys to tell me which element has 14 protons and how many protons does bromine have, okay? Again, this number on top tells you the number of protons. So I'll give you guys about 2 minutes to do that. You can check with your neighbor and then we'll go over it together. Okay, so let's go to number 1. Which element has 14 protons? So we'll have to take a look at the periodic table. So I zoomed in to the top right corner of the periodic table. Does anyone want to answer that question? Number 1, which one has 14 protons? Yeah. Yeah, silicon. Okay, see, it's the number 14 on the top. Again, this number right here tells you how many protons there are. So it's going to be silicon. So for number 1, you can either write the full name if you want. You can write silicon. Okay, but if you notice, it's the symbol is Si. You can just write Si if you want. Just whatever is more comfortable for you. These are pretty much interchangeable, regardless of which one you give me. I'll understand what that means. Okay, cool. Any questions on number 1? Easy peasy. All right, let's go to number 2. So we're looking at how many protons does bromine have. So if we take a look at the periodic table and look right here, bromine is right here. How many protons does bromine have? Yeah, 35. Number on top is 35. Okay, so we can just write it has 35 protons. Okay, so numbers 1 and 2 should be pretty simple. Let's go to number 3. This one's a little bit trickier. Which element has 5 protons and 4 neutrons? Anyone want to take a shot at that? Yeah. Yeah, it's going to be boron. Okay. How did you know it was boron? Yeah, exactly. That's exactly what you should look at. So I know there's 5 protons and 4 neutrons, right? So some people think, oh, do I add the protons and neutrons? But if you guys remember from earlier, it's the protons that tells you what the element is. So it doesn't matter if there's 4 neutrons, 100 neutrons, 1 billion neutrons. If it's 5 protons, it has to be boron. Okay, so that's kind of the point that I was trying to make with number 3. Okay, so even if it has 5 protons, 4 neutrons, it's going to be boron. Good catch on that. All right. Any questions on that? Okay. So we're gonna go on to the next type of question that'll be on your assignment, and then we're pretty much done. Okay, so here I'm gonna show you guys how to draw a picture of these atoms now with a little bit more detail. So let's work together and we'll draw a picture of a helium atom with 4 neutrons. Okay. So whenever you draw an atom, you want to know, first of all, how many protons there are, how many neutrons there are, and how many electrons there are. Okay, so I'm going to give you guys a minute. You can work with the person next to you. See if you guys can just figure that out for now. See if you can figure out how many protons, we already know there's 4, and how many electrons helium is going to have. So just jot that down on your paper. Take a minute to do that. So if we take a look at helium, we want to first figure out how many protons there are. So if we look on the periodic table, helium's up here on the top right. How many protons does helium have? 2, yeah. So super easy. We got 2 protons. Okay. And then earlier I said for today, we're going to assume that we have the same number of protons and electrons. So if we got 2 protons, how many electrons will helium have? 2. That's it. Okay, so we can draw the atom now. So we said that the protons and the neutrons go in the middle, right? So in the middle, we can just draw 2 protons, and you can organize them however you want. So I'm going to draw 2 protons. We have 4 neutrons. So we're going to draw 4 neutrons. And again, you can orient them however you want. Okay. The key thing is just make sure the protons and the neutrons are touching each other. Okay. So I'll jot that down for you guys if you want to jot it down. Okay, so the protons and the neutrons, they're going to be in the middle and they're going to be touching. So when your assignment is getting graded, that's what the TLs will be looking for. They'll be looking for, are the protons and neutrons in the middle? And Got to make sure they're touching each other in some way. Okay. And then lastly, we said the electrons are just kind of flying around. So you can just put the electrons somewhere on the outside. And the key thing about the electrons is that they are not touching anything. They're just kind of independent. And that's how you draw an atom. It's kind of the general form. Any questions on how to do this? Pretty simple. I'll leave it up there for a little bit.